All right, we're jumping right into lesson 1.1, that's linear equations. All of unit 1 we're going to be talking about different types of equations like square root equations, absolute value equations, quadratics. Today we're specifically talking about linear equations, and we're talking about those that only have one variable. So throughout Unit 1 you are going to see some themes and some important things to hold on to, one of them being inverse functions. So this is a list, not a comprehensive list, of inverse functions. A plus will undo a minus. So if I had a plus 5 in an equation, I can undo it by subtracting 5. If I had a times 7, I could undo that by dividing by 7. If I had a square root, I could undo it with a square. These go backwards as well, so if I had a minus 5, I could undo it with a plus 5. Any root will undo the same exact power, right? So a fourth root would undo a fourth power, fifth root with a fifth power. We're going to see more of this today. We're going to start off with linear equations. Like I said, that just means that there's no funny business, like no exponents, absolute values, square roots, things like that. On the left side, we have some examples of linear equations in one variable. That's what we're talking about today. The first and the third look really familiar. The second one, they can have fractions. That's fine, as long as there's not a variable in the bottom of the fraction. Those would be called rational functions. We are going to see those this unit as well. And they are allowed to have decimals. In the right-hand column, you see things that are not linear equations in one variable. The first one, for example, is not because it has an exponent. The second one is not because it has that variable in the bottom of the fraction. The third is a linear equation, actually. It's just not a linear equation in one variable. And the fourth one is a special case. It's not even an equation at all. It's just an expression. We saw those last class. So if there's no equal sign, it's not an equation. A solution to an equation is just something that makes that a true statement. So in this first example, we have x plus 4 equals 9. If we look at the answer, they've already solved it for us, x equals 5. We know that's the solution because 5 plus 4 does equal 9. In the second example here, 4x equals 24. We have x equals 4 as the solution. We know that's true because 4 times 6 is equal to 24, right? We have two properties here that we're going to keep using today and throughout the unit. They're called the addition property and the multiplication property of equality. The addition applies to addition and subtraction. The multiplication applies to multiplication and division. So with the addition property of equality, all it says is if we can add the same thing or subtract the same thing to both sides of any equation, that just keeps it balanced. The multiplication property of equality says we can multiply or divide by the same thing on both sides of an equation, as long as it's not 0, right? We can't divide by 0. Let me give you an example of the addition property. If I have x equals 3, if I add 7 to both sides, plus 7, plus 7, I have x plus 7 equals 10. This is the same equation, and I know it is, because if I take the initial equation, 3 plus 7 does equal 10. Here's an example of multiplication. X equals 4. If I multiply both sides by 6, I would have 6x equals 24. I know it's the same equation because 6 times 4 does equal 24. My initial equation is still true. I can multiply or divide by both sides. I can add or subtract by both sides as long as it's by the same number. It's just keeping that equation, like I said, very balanced. We're jumping straight into some examples, and I'm going to tell you what our workflow is. If you have parentheses, the first thing you want to do is get rid of those parentheses by distributing. After we distribute, then we're going to combine our like terms. After we combine our like terms, we're going to use the addition and subtraction properties of equality to try and get the variables to one side and the numbers to the other. Then we're going to use the multiplication property of equality to either multiply or divide both sides of that equation to try and get the variable all by itself isolated. So first, distribution. All we're doing is taking the number outside the parentheses and multiplying it in. So negative 3w, negative 3 times negative 4 is positive 12. Anything that doesn't get distributed just comes on down. Same thing with the 10. This is actually a negative 1. It doesn't say it, but it's a negative 1. So negative 1 times w is negative w. Negative 1 times negative 1 is negative 1. The second step I said is we're going to combine like terms. So these are like terms. These are like terms. What I mean by like terms is on each side of the equal sign, if they have the same exact variables or lack of variables to the same powers, you can combine them. So the things that I underlined have no variables. We can combine those. Anything that doesn't get combined just gets brought down. Same thing, 10 minus 1 is 9 minus w. Once we've combined our like terms, we're going to use the addition-subtraction property of equality to try and get all the variables to one side, all the numbers to the other. Doesn't matter which side which goes on. The variables can go to the left or right, same with the numbers. Most people prefer to get the variables to the left, so that's what I'm going to do here. To get the variables to the left, I'm going to add w. And I know I'm going to do that because addition will undo that. I'll have negative 2w plus 17 equals 9. trying to get the numbers to the right by subtracting 17. Negative 2w, those will go away, equals negative 8. If I divide both sides by the same thing, that's the multiplication property of equality. I can multiply or divide by the same thing, equals 4. W equals 4. That should be my solution. I'm not going to do this every single equation today, but I am going to do it for this one so you can see an example. If you want to make sure that answer is actually correct, that solution is actually correct, you can plug it into the initial equation. So I'm just, for everywhere there's a W, I'm just going to put in a 4. So negative 3, 4 minus 4, plus 5, equals 10 minus 4 plus 1. You can plug that directly into your calculator, the left side and the right side, or we can just go through and solve it step by step. That'd be negative 3, 0 plus 5. We're using PEMDAS here, right? 10 minus 4 plus 1 is 5. Negative 3 times 0 is 0. That makes 5. 10 minus 5 is 5. Check. We got the same thing on both sides. We know that W equals 4 is a correct solution to this equation. Like I said, I'm not going to do that every time, but it is good practice to go through and check your answers. I have another equation very similar. What I want you to do is pause the video, go and try and work this, and I'm about to show you the solution. You can check your solution. All right, I'm scrolling down now. When you finish, you should get V equals 11 as the solution to that equation. The next thing is something that everybody hates, right? It's fractions. But I have a good method to get rid of fractions. The first step we're going to do, before we distribute, before any of that, the stuff that we just did, we're going to get rid of every fraction in the equation. So the technically right way is to find the least common denominator. That would be the least common thing, least common multiple of those three things, 5, 12, and 15, which would be 30. If you can think that way, that's great, and you can multiply every different term by 30. A lot of people can't think that way, so what we're going to do is, or don't like to think that way, I should say, what we're going to do is we're going to multiply by every different denominator, 5, 2, and 15. We're going to multiply every single term. That means everything that's separated by a plus, a minus, or an equals. In this case, I have 4 terms, that one, that one, that one, and that one. I'm going to multiply every single one of them by every different denominator. So this first one I'm going to multiply by 5, 2, and 15. The second one, 5, 2, and 15. Third one, 5, 2, and 15. And this one over here, even though it doesn't have a denominator, it is a different term. So we have to multiply them all by the same thing. That's a part of that multiplication property of equality. All right, one thing you remember is things like 4 over 4, that's equal to 1, right? Things like 5x over 5, that's just equal to x. If you have the same thing on the top and bottom of a fraction, those will divide away to just 1. And so that's the concept that we're going to use here. We're going to divide away all the things that are in common. So on that first equation there, we have 5 over 5. I can divide those away. The second one, 2 over 2, divided away. 15 over 15, divided away. Sadly, on the last one, I don't have anything in common that I can divide away. All right. Now, what I'm going to do is multiply these by that. So 2 times 15 is 30 times m minus 2. I'm keeping the minus sign, minus. 5 times 15 is 75, parentheses, m minus 4. Keep the equal sign, right? 5 times 2 is 10, m plus 5. You're multiplying it by the whole top. I keep putting that parentheses. It's very important that you keep that. 2 times 5 times 2 times 15 is 300. I've got my handy calculator sitting next to me. All right, now, once we've done that, that's just one step that we've done, right? We got rid of the fractions, but now it's just a regular equation, just like we just did, right? That looks just like the last two that we did. We're going to follow the same steps now. Distribute, then combine like terms, then use the addition property of equality, then multiplication property of equality. When you distribute 30m minus 60, that's a minus 75m plus 300. I'm multiplying negative 75 times negative 4 to get that positive 300 equals 10m plus 50 plus 300. Next, combine like terms. So I have things like 30m and negative 75m. I have things like negative 60 and 300 that can combine. And I have things like 50 and 300 that can combine, right? I'm looking at on each side of the equal sign, what are my common terms? 30 minus 75 is negative 45m. Negative 60 plus 300 is positive 240. 10m had nothing to combine with, so I'm just bringing it down. And 30 plus 50 is 350. Next, addition property of equality to get all the variables on one side. I like to move my variables to the left. And that gives me negative 55m plus 240 equals 350. Again, addition property of equality, subtract 240 from both sides is a legal move. That will get rid of that one. Negative 55m equals 110. Then I can use the multiplication property of equality, divide both sides by negative 55, and m equals negative 2. Again, you can go back and check this the same exact way we checked our original one. We can go back and sub in a negative 2 for every single m. You could do that in your calculator, or you could do it by hand in your original equation. All right, I have one more just like that, and I'm going to help you get it started, and I want you to finish it the same exact way as the last one. We're going to multiply by every different thing in the denominator. That's a 2, a 4, and a 3, right? So I'm going to multiply every fraction by 2, 4, 3, 2, 4, 3, 2, 4, 3, 2, 4, 3. Even though it's not a fraction, it is a term, right? Separated by a plus. Get rid of all the things in common. Get rid of all the things in common. Get rid of all the things in common. And there's nothing in common on that last one. Here, 4 times 3 is 12. Y plus 5. I'm getting the 12 by multiplying those things. 2 times 3 is 6. Y minus 2. Notice I brought that minus sign down. Same thing with the equal sign. 2 times 4 is 8. Y plus 7. And 1 times 2 times 4 times 3 is 24. And I'm going to leave you to finish solving that. Again, I'm about to slide down and show you the answer, so take a minute, go through and try and solve it, get your answer, and then check it against mine. Your answer should be y equals negative 4. All right, these skills are transferable to word problems. So for example, if we have the option to either buy a car or rent a car, we could either buy a car straight up for $8,800, buy, or we could rent a car for $2,500 plus $225 per month. The hardest part of these problems is to write a model for the cost to lease the car for T months. So if I want to lease the car for T months, it's going to cost me that initial down payment of $2,500, and then it's going to cost me $225 per month. Part B, after how many months will the cost be equal to the cost to just buy the car, right? The cost to buy the car is $8,800. $8,800 equals 2,500 plus 225m. I now have just a regular equation, right? I can use the addition property of equality, subtract 2,500 from both sides, and I get 6,300 equals 225m. I can divide by 225 using the multiplication property of equality. Divide by 225. I don't know that one off at the top of my head, believe it or not. 6,300 divided by 225, and I get 28. So it takes 28 months, and I've already paid the full price of the car. So after leasing the car for 28 months, you're just about better off, or you are better off, to have just bought the car if you have the money for it. All right, we're almost to the end, I promise. There are some other ways that these can work out. So we're just going to work each of these and see how they work out, right? The first one, we distribute. We get 6x minus 1 equals 6x minus 4. I'm sorry, that's not a 1. I didn't distribute the 3 in. 6x minus 3 equals 6x minus 4. What we can do is now use the addition property of equality to try and get our variables to one side, and then we realize pretty quickly that we have something that's just not true. We can keep trying, right? We can keep trying to make this work, but we're just never going to end up with something that's true. And this equation is never going to be true. No matter what I put in, this equation is never going to be true. It's actually no solution. I could put any number in the world in for x and never get a correct answer. This is called a contradiction equation. Contradiction. Because there is no correct answer. All right, the second way this can work out, we're going to follow the same exact steps that we have been. We're going to distribute, combine like terms, addition, subtraction, multiplication, division. So when you distribute, you get 6x minus 3 equals 6x minus 4 minus 1. Oh, I'm sorry, that's a plus 1. I don't need to change that plus 1. All right, combine like terms, you have 6x minus 3 equals 6x minus 3. Try and move everything to one side using the addition property of equality. That'd be negative 3 equals negative 3. Again, you can keep piddling with this as long as you want, and you're always going to actually end up with something that is true, right? This is always true. What we would say is all real numbers are solutions. All real numbers or solutions. This is, if you end up with anything like this, this is actually called an identity equation. And what that means is it doesn't matter what number you pick. I could put a 4, I could put a 3, I could put a 0, I could put a negative 15. No matter what number I pick, it is going to make that equation true. All right, so we have a contradiction. That means no answer is true. We have an identity. That means any answer is true. And then we have one more type, 6x minus 3 equals 5x minus 4. Subtract the 5x. And this looks like it's working out much better than the last ones, right? And we actually get a solution, right? We actually get one solution. This one is called a conditional. Most of the ones that we worked in class today have been conditional equations. And they're called conditional equations because they're true on the condition that x equals a specific number. So this equation is only true when x equals -1. All right, that's the end of 1.1. I hope you guys have enjoyed it. Y'all let me know if you have any questions.